Chapter 11.1, the fundamental counting principle. A tree diagram, so named because of its branches, shows the number of outcomes possible. For example, you have a pair of blue jeans and a pair of black jeans. You have a red, green, and yellow shirt. You have a pair of sneakers and a pair of loafers. How many different outfits can you make? Well, a tree diagram can help us determine that. And each branch is for jeans, shirts, and sneakers. So let's start our first branch saying that we have blue jeans and black jeans. Okay, and then I have three shirts, red, green, and yellow, meaning with my blue jeans, I can wear a red shirt, a green shirt, or a yellow shirt. And with my black jeans, I can wear a red shirt, a green shirt, or a yellow shirt. Now, additionally, I have two different kinds of shoes. So if I wear my blue jeans and a red shirt, I can either wear sneakers or loafers for a different outfit look. With the blue jeans and green shirt, I also have the option of either sneakers or loafers. With the blue jeans and yellow shirt, sneakers or loafers. With the black jeans and a red shirt, sneakers or loafers. With the black and green, sneakers or loafers. And with the black and yellow, sneakers or loafers. Meaning each one of these paths is a possible outfit that I have. So I can have blue, red with sneakers, blue, red with loafers, blue, green with sneakers, blue, green with loafers, blue, yellow with sneakers, blue, yellow with loafers, or black, red with sneakers. So black, red, sneakers, black, red, loafers, black, green, sneakers, black, green, loafers, black, yellow, sneakers, black, yellow, loafers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different outfits can be made. So a tree diagram, it's a way for us to organize our information and not only determine how many different outfits we can make, in this case, but what each outfit looks like. You might notice though, with very many options, it gets very cumbersome, right? So one thing that comes from this is we usually don't really need to know what, in this case, each particular outfit looks like, but just how many possibilities there are. Now, notice that the total number of outfits can be obtained by multiplying the number of choices for the jeans, which was 2 choices for the jeans, by the number of choices for the shirts. I had 3 choices for shirts, red, green, and yellow, by the number of choices for shoes, 2 choices for shoes. Notice 2 times 3 is 6, times 2 is 12. This is called the fundamental counting principle. The number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. So if you own 30 pairs of jeans, 20 t-shirts, and 12 pair of shoes, you have 30 times 20 times 12, or 7,200 possible outfits. The fundamental counting principle. And that's what we're going to practice in this section. Very important concept. So let's look at how we can use that to answer some questions. Now also, as I do the fundamental counting principle, I'm going to develop a method that's going to help me not only in future sections, but just to keep my information straight. And I'm going to think of using this fundamental counting principle in terms of filling in the blanks of how many different branches there are. So if a restaurant offers 8 appetizers and 10 main courses, in how many ways can a person order a 2-course meal? Because there are 2 courses, I know I have 2 blanks to fill in. One for appetizers, of which I have 8 to choose from, and one for main courses, of which there are 10. And when I'm counting things, the fundamental counting principle of how many ways something can occur is always multiply. Okay, so 8 times 10, you have 80 options for a meal. A student is planning a 2-part trip. Oh, if it's a 2-part trip, now again, this is something I'm doing to also help us in future sections. The first leg of the trip is from San Francisco to New York, and the second leg is from New York to Paris. From San Francisco to New York, travel options include airplane, train, or bus. So there's 3 travel options. From New York to Paris, the options are limited to airplane or ship, so only 2. How many ways can the 2-part trip be made? 6 different ways. And once again, if I needed to know what those ways were, what each 6 method was, each of the 6 methods, then I would make my tree diagram. You are taking a multiple choice test that has 5 questions. Each of the questions has 3 answer choices, with 1 correct answer per question. You can select one of these 3 choices for each question and leave nothing blank. And how many ways can you answer the questions? Sorry about that. Typo again. All right. 5 questions. That means 1, 2, 3, 4, 5 options to fill in. Each of the questions has 3 answered choices with 1 correct answer per question. If you select one of these 3 choices and leave nothing blank, okay, then that means the first one I have 3 choices, and I'm going to choose one of those 3 choices. The second is 3 choices. The third, 3 choices. The fourth, 3 choices. The fifth, 3 choices. So I can type this in my calculator. Notice what it is also, a shortcut way to calculate it is 3 to the 5th, and 9 times 9 is 81 times 3, or there are 243 different ways that you could answer those questions. What if leaving a question blank was an option? Right? Then the only difference that would make, you still have 5 questions that you have to answer, but now instead of 3 options, there's 4, adding the option of leaving the question blank. And for each of the 5 questions, you have the option of leaving it blank. Notice one option is just handing in a blank paper. Another option is getting every question correct and everything in between. In other words, 1,024 different ways you could answer those questions. License plates in a particular state display 2 letters followed by 3 numbers. How many different license plates can be manufactured for this state? Okay, 2 letters followed by 3 numbers. Notice already how this fill in the blank idea is already helping us organize our information, and it's really going to help us in the coming sections. So get used to thinking about this fundamental counting principle as filling in the blanks. 2 letters. Okay, so I need to know how many letters there are. There's 26 letters in the alphabet. So the first two, I can have 26 in the first blank, 26 choices in the second blank, and then followed by 3 numbers. Well, there are 10 digits, right, including 0 through 9. So I have an option of being able to put a 10 in each of the last 3 blanks. And if I plug that in my calculator and multiply it all together, I get 676,000 different license plates are possible. What if we had the same question, but it said you could not repeat numbers or letters? I still have 5 options, 2 letters and 3 numbers, but this time after I put a 26 in my first spot, if I cannot use that letter that I put in the first spot again, I can't repeat, then there's only 25 choices left for letters to put in the second spot. Okay, my first number, I still have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 that I can choose, so 10 options. But once I have placed a number in this spot, if I can't repeat digits, then there are only 9 letters left, and after that, only 8 letters left. Or 468,000 license plates if you can't repeat any of your digits. How many different phone numbers, including area codes, are possible in the United States? What's the first thing you need to figure out? Exactly how many blanks there are. It says including area code, so we have a 3-digit area code, and then we have 3 digits for a prefix, followed by 4-digit numbers. Okay, now I got to be careful about filling in these blanks because I cannot begin a phone number with a 0 or a 1. Right? I think that's the only restrictions, a 0 or 1. So instead of a 10 here, I only have 8 choices. Now, the next 2 numbers in my area code, I can put any one of our 10 digits. But here I am again at the beginning of my prefix. I cannot put a 0 or a 1. But I believe the rest of the digits in a phone number can use any numbers from 0 through 9. So 8 times 8 is 64 with 1, 2, 3, 4, 5, 6, 7, 8 zeros. So 6,400,000,000 possible phone numbers available in the United States. Okay, I'll see you for chapter 11.2. Let me know if you have any questions on the fundamental counting principle.